The birth of a genius Woolsthorpe Manor, Lincolnshire, England, Christmas Day, 1642. In a small farmhouse, a premature infant enters the world so tiny he could fit in a quart mug. His father is already dead, buried 3 months before his son's birth. The child is not expected to survive the night. His name is Isaac Newton. But on this cold December morning, no one imagines he will live to revolutionize human understanding. His mother, Hannah, wraps him in blankets, praying desperately. Against all odds, the fragile baby clings to life. England is torn by civil war. King Charles battles Parliament. The world is violent, uncertain, medieval. But in this quiet corner of rural England, a mind is taking shape that will illuminate the darkness of ignorance. Isaac survives his first week, then his first month. His tiny body grows stronger, though he remains frail throughout childhood. You are watching Iconic Figures. Stay with us until the end to discover how this story shaped history. When Isaac is 3 years old, tragedy strikes again. His mother remarries. Barnabas Smith is a wealthy rector, 63 years old. He wants Hannah, but not her young son. Isaac is left behind at Woolsthorpe with his grandmother. His mother moves to a nearby village with her new husband. For a sensitive child, this abandonment cuts deep. Isaac never forgives her. The wound festers for life. He grows up angry, isolated, suspicious of affection. He trusts books more than people. His grandmother is kind but distant. Isaac spends hours alone, wandering the fields, observing nature. He watches apples fall from trees. He studies the movement of clouds. He traces shadows across the ground. His mind is constantly questioning, measuring, analyzing. Why does the moon follow predictable paths? Why do objects fall downward? When Isaac is 10, his stepfather dies. His mother returns to Woolsthorpe with 3 new half-siblings. Isaac is no longer the center of attention. He's expected to help manage the family farm, but farming bores him. He's caught reading when he should be tending sheep. His livestock wander into neighbors' fields. His mother is frustrated. His relatives think he's useless, a dreamer who will never amount to anything. But his uncle, William Ascough, recognizes something special. He's a Cambridge graduate and sees Isaac's potential. In 1655, Isaac is sent to the King's School in Grantham, 7 miles from home. He boards with an apothecary named Clark. School is difficult socially. Isaac is awkward, intense, socially inept. Other boys mock him. One day a bully kicks him in the stomach. Isaac, small and weak, is humiliated, but instead of retreating, he challenges the bully to a fight after school. Through sheer determination, he wins. Then he vows to defeat the boy academically as well. Within months, Isaac rises to the top of his class. Competition becomes his fuel. He must be first, always first. Second place is failure. He lodges in the apothecary's attic, surrounded by bottles, herbs, mysterious substances. His curiosity is ignited. He builds mechanical devices, sundials, water clocks, model windmills. His hands are as clever as his mind. He draws elaborate diagrams in his notebooks, geometric patterns, mathematical puzzles, observations of nature. But in 1659, his mother summons him home. His stepfather's estate is settled. She needs Isaac to run the farm. At 16, Isaac is pulled from school to become a farmer. His education seems finished. He's miserable. He neglects the farm work. He sits under trees, reading Aristotle while the crops go untended. His mother finally admits defeat. Her son is no farmer. He's something else, something she doesn't understand. Uncle William intervenes again. He convinces Hannah to send Isaac to university. In June 1661, at age 18, Isaac Newton enters Trinity College, Cambridge. He arrives as a subsizar, a poor student who earns his keep by serving wealthier students. He empties chamber pots, cleans boots, serves meals. It's humiliating, but Cambridge is a gateway to knowledge. The university still teaches medieval philosophy. Aristotle dominates. The scientific revolution is barely acknowledged. But Newton discovers contraband, the forbidden new ideas of Galileo, Descartes, Kepler. He reads voraciously, secretly. He fills notebooks with radical thoughts, questioning everything Aristotle taught. He studies mathematics with fierce intensity. Euclid's geometry, algebraic equations. He quickly surpasses his teachers. His notebooks reveal a mind reaching beyond what anyone is teaching. He's educating himself. In 1764, he reads Descartes' geometry and is dissatisfied. The methods seem clumsy, limited. He begins developing his own mathematical techniques, what will eventually become calculus, but he shares nothing. His work remains locked in private notebooks. He trusts no one. In 1665, he receives his bachelor's degree. He's planning to continue for his master's when disaster strikes. The bubonic plague reaches London. Thousands die weekly. The death toll climbs toward 100,000. Cambridge closes. Students are sent home. Newton returns to Woolsthorpe, expecting a brief interruption. Instead, he remains isolated there for nearly 2 years. The most productive 2 years in the history of science. Alone in the countryside, with no distractions, no obligations, Newton's genius explodes. He investigates the nature of light, experimenting with prisms in his darkened room. White light, he discovers, is composed of all colors. He's observing the spectrum, understanding refraction. He grinds his own lenses, builds his own equipment. His experiments are meticulous, obsessive. He begins developing his theories of motion and gravity. Why does the moon orbit the Earth? The famous apple story may be true. Newton himself told it late in life. Sitting in the garden, he watches an apple fall. Why does it fall straight down? What force pulls it? And if that force extends to the apple, how far does it reach? To the clouds? To the moon? What if the same force that pulls the apple pulls the moon, but the moon's sideways motion keeps it in orbit? It's a flash of insight that unifies heaven and earth. The same laws govern both. He begins calculating. The mathematics are complex, but he's inventing new mathematics to solve them. He develops the method of fluxions, his version of calculus. It allows him to calculate rates of change, instantaneous velocities. By 1666, at age 23, Newton has laid the foundations for 3 revolutionary fields: optics, mathematics, physics. Each one would make a career. He's done all 3 in isolation, but he publishes nothing. He shows no one. The work stays hidden in his notebooks. He's paranoid about criticism, about theft. He'd rather possess truth privately than share it publicly. In 1667, the plague subsides. Cambridge reopens. Newton returns, his mind transformed. He's no longer a student. He's something unprecedented, a genius operating beyond all known boundaries. The discoveries that changed the world. Cambridge, 1667. Isaac Newton returns from his plague years with revolutionary ideas locked inside his mind. He becomes a fellow of Trinity College. He's financially secure now, no longer a servant to wealthy students. But he remains isolated, obsessive, sleeping only a few hours nightly. His room is cluttered with experiments. His mathematics tutor, Isaac Barrow, recognizes Newton's extraordinary abilities. He sees what others miss. In 1669, Barrow does something remarkable. He resigns his prestigious Lucasian professorship of mathematics. His reason: so that Newton, only 26 years old, can have the position. Newton becomes Lucasian professor, a post he'll hold for 30 years. The same chair Stephen Hawking will later occupy. His lectures are technically brilliant, but incomprehensible to most students. Sometimes no one attends at all. Newton doesn't care. He's not teaching for them. He's working through problems aloud, organizing his thoughts. In 1672, he presents his first major work to the Royal Society, his experiments and theories on light. He's built a reflecting telescope using mirrors instead of lenses. It's compact, powerful, revolutionary. The Royal Society is impressed. He's elected a fellow. His name begins to circulate among Europe's intellectuals, but then Robert Hooke, the Society's curator of experiments, criticizes Newton's theory of light. Hooke suggests the ideas aren't original, that others have proposed similar theories. The criticism is mild, professional. Newton reacts with rage disproportionate to the offense. He writes bitter, defensive responses. He threatens to withdraw from all scientific communication. He can't tolerate criticism or contradiction. This pattern will repeat throughout his life. Every disagreement becomes personal, every debate a war. He retreats from public science for years, nursing his wounds, trusting no one. But privately his work continues. He's obsessed with alchemy, conducting thousands of experiments. His laboratory is filled with furnaces, crucibles, mysterious substances. He's searching for the philosopher's stone. By modern standards, it's pseudoscience. But for Newton, alchemy and physics are connected quests to understand matter's nature. He writes over 1 million words on alchemy. Most remain unpublished, unread until the 20th century. He also studies theology intensely. He reads the Bible in Hebrew and Greek, analyzing every passage. He develops heretical views, denying the Trinity. If discovered, he could be expelled from Cambridge. His religious beliefs remain secret. He lives in constant fear of exposure, of losing everything. In 1679, Robert Hooke contacts him again. Hooke is now secretary of the Royal Society. He writes courteously, inviting Newton back to scientific discourse. He poses a question about planetary motion. Newton responds coldly, but begins thinking about the problem. His dormant ideas about gravity reawaken. He realizes he can prove that an inverse square law of gravity produces elliptical orbits, exactly as Kepler observed. The mathematics are complex, but Newton has the tools, his calculus, his geometric brilliance. In 1684, astronomer Edmund Halley visits Newton at Cambridge. He asks a crucial question. What path would a planet follow if gravity decreased with the square of distance? Newton answers immediately, an ellipse. Halley is astonished. Can Newton prove it? Newton claims he did the calculation years ago, but lost the papers. He'll redo it. 3 months later, he sends Halley a 9-page treatise. It's extraordinary, revolutionary. Halley recognizes its importance instantly. He begs Newton to expand it into a full work. Newton begins writing. Within 18 months, he produces one of the greatest scientific books ever written. Philosophia Naturalis Principia Mathematica, the mathematical principles of natural philosophy. The Principia, as it becomes known, is published in 1687. Halley pays the printing costs himself. It's written in Latin, dense with mathematics, nearly impenetrable. But its impact is immediate. Newton presents 3 laws of motion. First, objects remain at rest or in uniform motion unless acted upon. Second, force equals mass times acceleration. Third, every action has an equal and opposite reaction. These laws describe all motion, on earth and in the heavens. They're universal, elegant, complete. He then presents his law of universal gravitation. Every mass attracts every other mass. The force is proportional to the product of their masses and inversely proportional to the square of the distance between them. One equation explains the apple's fall, the moon's orbit, the tides, comets, planetary motion, everything. For 2,000 years, heaven and earth obeyed different laws. Newton unifies them with mathematics. He explains the flattening of Earth at the poles, the precession of the equinoxes, the irregularities in the moon's motion. He calculates the mass of the Sun, Jupiter, and Saturn. His predictions are confirmed by observation. The Principia transforms physics from speculation into mathematical science. It's the foundation of classical mechanics. Voltaire later writes, "There were not above 50 persons in Europe who understood it, but these 50 ruled the world." Newton becomes famous across Europe. He's recognized as the supreme genius of his age, but he's also paranoid. He fears others will steal credit. He publishes reluctantly, only when forced. In the Principia, he deliberately makes some sections obscure to prevent little smatterers from understanding. He guards his methods jealously. He's already invented calculus but hasn't published it. In Germany, Gottfried Leibniz independently develops calculus and publishes it in the 1680s. Different notation, different approach, but essentially the same mathematics. At first, Newton acknowledges Leibniz's work. Both men developed the method independently, but Newton's supporters begin accusing Leibniz of plagiarism. The dispute escalates. By the 1690s, it becomes a bitter international controversy. England versus the continent. Newton, now older and more vindictive, secretly fuels the attacks on Leibniz. When the Royal Society investigates, Newton anonymously writes the committee report exonerating himself. He publishes old manuscripts to prove his priority, backdating his discoveries. Leibniz is devastated. His reputation is damaged. He dies in 1716, bitter and forgotten. Newton has won, but the victory is ugly. The calculus war poisons mathematics for decades. British mathematicians use Newton's inferior notation, isolating themselves from continental advances. In 1689, Newton is elected to represent Cambridge in Parliament. He serves twice, but rarely speaks. His only recorded comment, asking an usher to close a window because of a draft. He's not a politician. He's uncomfortable with people, terrible at small talk. In 1693, he suffers a severe mental breakdown. He stops sleeping, becomes paranoid, writes bizarre letters. He accuses friends of conspiring against him. He claims he wants to withdraw from the world. The episode lasts months. Its cause remains mysterious. Mercury poisoning from alchemy, exhaustion, mental illness. He recovers slowly but is changed. His creative scientific work is essentially finished. In 1696, he leaves Cambridge for London. He's appointed warden, then master of the Royal Mint. It seems a strange position for the world's greatest scientist, but Newton takes it seriously. England's currency is debased. Counterfeiters are rampant. Newton becomes a ruthless administrator. He personally interrogates suspects, tracks criminals, sends counterfeiters to the gallows. He oversees the Great Recoinage, reforming England's entire monetary system. He's efficient, merciless, and successful. The mint becomes his new obsession. In 1703, Robert Hooke dies. Newton is finally free of his old rival. He's immediately elected president of the Royal Society. He'll hold the position for 24 years, ruling it like a monarch. In 1704, he publishes Optics, his work on light and color. It's more accessible than the Principia. It describes his prism experiments, his theories of refraction and reflection. It's immediately influential. In 1705, Queen Anne knights him. He becomes Sir Isaac Newton, the first scientist so honored. He's wealthy, famous, powerful. But he's also alone. He never married, had no children. His niece, Catherine Barton, manages his household. She's beautiful, witty, social, everything he's not. Rumors swirl about her relationship with Halifax, a nobleman. Newton seems not to care or pretends not to. He spends his final decades revising the Principia, battling Leibniz, ruling the Royal Society. He's admired, feared, respected, but he's not loved. He's too cold, too proud, too suspicious. Battles and challenges, London, early 1700s. Sir Isaac Newton sits in his grand house, surrounded by power and prestige. He's master of the Mint, president of the Royal Society, the most celebrated scientist in Europe. But his soul is restless, combative. He cannot enjoy his triumph without crushing his rivals. The war with Leibniz intensifies. What began as a priority dispute becomes personal vendetta. Newton controls the Royal Society. He uses it as a weapon, orchestrating attacks on Leibniz. In 1712, the Royal Society forms a committee to investigate who invented calculus first. Newton secretly writes the committee's report himself, naturally concluding in his own favour. The document Commercium Epistolicum is published and distributed across Europe. Leibniz is devastated. He responds with pamphlets, but Newton's power and prestige overwhelm him. Newton writes anonymous reviews praising his own work and attacking Leibniz viciously. For Newton, it's not enough to be right. His enemies must be destroyed, their reputations ruined. Leibniz's health fails. He dies in 1716, broken and isolated. Few attend his funeral. Newton has won, but the victory reveals the darkness in his character, genius paired with cruelty. But Newton faces other battles. His religious beliefs remain heretical and dangerous. He denies the Trinity, believing it's a later corruption of Christianity. If exposed, he'd be ruined. He writes hundreds of thousands of words on biblical prophecy, trying to decode divine plans. He calculates the date of the apocalypse, 2060, he concludes, based on biblical chronology. These writings remain secret. He shares them with no one, terrified of persecution. His alchemical work also continues obsessively. His laboratory at the Mint operates day and night. He's searching for the fundamental principles underlying all matter. Modern chemistry is born from such searches. But the work is secret, coded in symbols. He fears ridicule if his experiments become public. By the 1710s, Newton's creative scientific work has ended. He produces no new theories. Instead, he revises the Principia endlessly. The second edition appears in 1713, the third in 1726. Each revision adds detail, responds to critics, tightens arguments, but the core remains unchanged. His role becomes authoritarian. He rules the Royal Society with iron control. He demands loyalty, punishes dissent. Scientists fear contradicting him, even when he's wrong. John Flamsteed, the astronomer royal, clashes with Newton over astronomical data. Flamsteed has spent decades making precise observations. Newton wants the data for his calculations. Flamsteed resists, wanting to publish his complete perfected work. Newton grows impatient. Using his influence, Newton arranges for Flamsteed's data to be forcibly published without permission. The edition is riddled with errors. Flamsteed is humiliated. He buys copies and burns them. When Flamsteed finally publishes his own complete star catalogue, Newton is dead. The wound lasted decades. Another conflict erupts with Nicolas Fatio de Duillier, once Newton's closest friend. Fatio was young, charming, brilliant. Newton's letters to him suggest deep emotional attachment. Some scholars see hints of romantic feelings, though the nature of their relationship remains debated. But Fatio becomes mentally unstable, joining a radical religious sect, prophesying the end times. Newton distances himself. The friendship ends abruptly, painfully. Newton never forms another close bond. His isolation deepens. He trusts no one fully. His genius is paired with profound loneliness. In 1722, Newton suffers inflammation of the lungs. His health begins declining. He's 79, ancient by 18th century standards, but his mind remains sharp. He continues working on biblical chronology, trying to establish exact dates of ancient kingdoms. His chronology of ancient kingdoms attempts to correlate Egyptian, Greek, and biblical histories. It's ingenious, but ultimately flawed. His methodology is questionable, his conclusions often wrong, but it reveals his compulsion to impose mathematical order on everything, even history itself. In 1724, he moves to Kensington, then a village outside London, seeking cleaner air. His niece, Catherine, and her husband care for him. He's wealthy, comfortable, honored. Visitors come seeking wisdom. He receives them graciously, but reveals little. "I don't know what I may seem to the world," he says, "but to myself I seem only like a boy playing on the seashore, finding now and then a smoother pebble or prettier shell, while the great ocean of truth lay undiscovered before me. It's false modesty, but it reveals something true." He knows how much remains unknown. His religious doubts persist. He fears judgment, divine and human. In early 1727, his health worsens dramatically. Kidney stones cause excruciating pain. He suffers attacks of gout. He can barely move, but he refuses to complain. On March 2nd, he chairs his last meeting of the Royal Society. He can barely stand. By mid-March, he's confined to bed. The pain is constant. Doctors can do nothing. He refuses communion from the Anglican Church. His heretical beliefs remain unspoken but firm. On March 20th, 1727, Isaac Newton dies at age 84. His last days are marked by suffering but also dignity. He faces death as he faced life, alone. His body lies in state in Westminster Abbey, an unprecedented honor for a commoner, for a scientist. Voltaire attends the funeral. He's amazed that England honors a scientist as other nations honor kings. Newton is buried in Westminster Abbey among monarchs and poets. The inscription reads, "Let mortals rejoice that so great an ornament of the human race has existed." But Newton left no direct heirs. His personal papers reveal his secrets, the heretical theology, the alchemy, the coded manuscripts. His executors are shocked. They suppress the religious writings for centuries, fearing scandal. The alchemical work is dismissed as embarrassing, the ravings of senility. Only in the 20th century is it properly studied. John Maynard Keynes, who purchased Newton's papers in 1936, calls him not the first of the age of reason, but the last of the magicians. Newton was two people: the rational scientist who discovered natural laws, and the mystic who searched for divine secrets. He compartmentalized brilliantly, keeping his contradictions separate, but both parts were essential to who he was. His inability to trust, to love, to connect. These weren't incidental. They were woven into his genius. He needed isolation to think. He needed obsession to create. His psychological wounds fueled his achievements, but they also ensured he died alone, admired but not loved, honored but not understood. The Last Years and the Legacy March, 1727. Isaac Newton's death reverberates across Europe. The age of giants has lost its greatest mind, but what Newton left behind is more than equations. It's a new way of understanding reality. Before Newton, the universe was mysterious, capricious, governed by divine whim or Aristotelian philosophy. After Newton, the universe became a machine, predictable, mathematical, comprehensible. The poet Alexander Pope captures the transformation. Nature and nature's laws lay hid in night. God said, "Let Newton be," and all was light. But the light Newton provided revealed both beauty and coldness. A clockwork universe operates without purpose. His laws describe motion perfectly but explain nothing about why. The universe simply obeys equations. This mechanistic worldview dominates science for 2 centuries. Newton's physics becomes unquestioned truth. Engineers use his laws to build bridges, canals, machines. The Industrial Revolution rests on Newtonian mechanics. Astronomers use his gravitation to predict planetary positions with stunning accuracy. In 1758, Halley's comet returns exactly as Edmund Halley predicted, using Newton's equations, 16 years after Halley's death. It's the ultimate vindication. Newton's laws work across decades across the solar system. In 1781, William Herschel discovers Uranus. Its orbit is calculated using Newton's mathematics. In 1846, irregularities in Uranus's orbit lead astronomers to predict another planet. Neptune is found exactly where Newton's laws said it must be. Every success reinforces Newton's dominance. Physics becomes synonymous with Newtonian physics. But Newton's personal papers reveal a stranger, more complex figure than the public image. His religious writings fill millions of words. He studied biblical prophecy obsessively, seeking hidden patterns. He calculated the precise dimensions of Solomon's temple, believing it encoded cosmic truths. He tried to reconstruct the original Christianity before what he saw as corruptions by later councils. These writings are suppressed for over a century. Cambridge refuses to publish them, fearing controversy. His alchemical experiments are dismissed as eccentricity, embarrassing delusions from a time before real science. Only in the 20th century do scholars recognize that alchemy, theology, and physics were unified in Newton's mind. He wasn't compartmentalizing, he was searching for a single truth underlying all reality. His alchemy sought to understand matter's transformation. His physics sought mathematical laws. His theology sought God's design. All three were aspects of one quest, to read the mind of God through nature's book. In 1905, Albert Einstein publishes his theory of special relativity. Newton's absolute time and space are questioned. Time isn't universal. Space isn't fixed. They're relative, flexible, interconnected. In 1915, Einstein's general relativity replaces Newtonian gravity. Gravity isn't a force, but curved space-time. Mercury's orbit, which Newton's laws couldn't quite explain, fits Einstein's equations perfectly. Newton's physics isn't wrong. It's a special case, an approximation that works at everyday speeds and scales. But at high velocities approaching light speed or near massive objects, Einstein's relativity is necessary. Still, Newton's laws remain the foundation. Engineers, physicists, and astronomers use them daily. Every spacecraft trajectory, every satellite orbit, every mechanical design relies on Newton's equations. The Apollo missions to the moon, calculated using Newtonian mechanics. They worked flawlessly. Newton's Principia remains one of the most influential books ever written. It created modern physics. His method, mathematizing nature, making precise predictions, testing them against observation, became science's template. Before Newton, natural philosophy was speculation. After Newton, physics demanded mathematical rigor. His influence extends beyond science. Enlightenment thinkers saw Newton as proof that reason could unlock all mysteries. Voltaire, Kant, Locke, all built philosophies inspired by Newton's success. If Newton could discover nature's laws, perhaps humanity could discover laws of economics, politics, ethics. The Enlightenment's faith in progress, reason, and natural law flows directly from Newton's achievements. But Newton himself would have been uncomfortable with this secular interpretation. He saw his work as revealing God's design, not replacing God with mathematics. His famous quote, "Gravity explains the motions of the planets, but it cannot explain who set the planets in motion. God governs all things." He believed his discoveries proved divine intelligence, not natural self-sufficiency. In 1936, economist John Maynard Keynes purchases Newton's unpublished papers at auction. Reading them, he's astonished. Newton, the rational scientist, vanishes, replaced by Newton the mystic. Keynes writes, "Newton was not the first of the age of reason. He was the last of the magicians." This realization transforms Newton's scholarship. He's no longer the pure rationalist, but something stranger, a transitional figure. One foot in medieval mysticism, one in modern science. He bridges two worlds, belonging fully to neither. His loneliness, his inability to connect, now seems essential rather than incidental. He lived between paradigms, translating divine mysteries into mathematical language. The psychological cost was isolation. The intellectual achievement was revolutionary. Newton never married. He formed no lasting intimate relationships. His legacy is intellectual, not personal. No children carried his name, but millions of scientists carry his methods. Every physicist who writes equations, who makes predictions, who tests hypotheses, they're Newton's descendants. In 1967, the unit of force is officially named the Newton. It's fitting. Force was central to his physics. His face has appeared on currency, stamps, monuments. His name adorns institutions worldwide. But perhaps the greatest tribute is invisible, the assumptions we inherit without knowing. We assume the universe operates by consistent laws. We assume mathematics describes reality. We assume observation reveals truth. These aren't obvious. They're Newton's worldview, so successful we've forgotten their assumptions. Ancient and medieval thinkers didn't think this way. Different cultures don't think this way naturally. Newton taught us to see the world as a mathematical structure. That vision dominates modernity. His coldness, his vindictiveness, his cruelty to rivals, these are harder to celebrate. The calculus war with Leibniz stained his reputation. His treatment of Flamsteed and others revealed pettiness. He was human, flawed, sometimes cruel. Genius doesn't confer virtue, but it's worth asking. Could he have achieved what he did without those flaws? His paranoia made him secretive, hoarding ideas until they were perfect. His competitiveness drove him to outwork everyone, to solve problems others abandoned. His isolation freed him from social distractions, allowing total focus. His inability to trust meant he relied only on his own reason, never accepting authority uncritically. The wounds and the genius may have been inseparable. To wish him happier might be to wish him less. In the end, Newton gave humanity a gift and a burden. The gift, a universe of order, where reason can discover truth. The burden, a universe without inherent meaning, where we must create our own purpose. He removed God from the daily operation of nature, replacing miracles with mathematics. Religious thinkers debated whether this honored or diminished the divine. Scientists, freed from theological constraints, built the modern world on his foundation. 3 centuries after his death, we're still living in Newton's universe. Yes, Einstein refined it. Quantum mechanics revealed stranger layers, but for everyday experience, Newton remains correct. The apple still falls. The moon still orbits. The laws Newton discovered still govern. In Cambridge, his rooms at Trinity College are preserved. Tourists visit, hoping to glimpse the ghost of genius. In Westminster Abbey, his tomb receives flowers, tributes from students and scientists. His Principia is still read, still studied, still revered. One of the few scientific works to achieve timeless status. And somewhere, in every physics classroom, on every exam, in every laboratory, Newton's laws are written. F equals ma. For every action, an equal and opposite reaction. Universal gravitation. Simple equations containing infinite implications. The boy who was too small to survive became the mind too large to comprehend. The abandoned child who trusted no one gave humanity a universe it could trust completely. The solitary genius who died alone left a legacy that will outlive civilizations. Isaac Newton didn't just discover laws of nature. He taught us that such laws exist, that we can find them, that reason illuminates reality. That may be the greatest discovery of all. On a winter night in 1642, a premature baby gasped his first breath against overwhelming odds. 84 years later, when he took his last breath, the world had changed forever. The universe Newton was born into was mysterious, magical, unknowable. The universe he left behind was mathematical, predictable, illuminated. He didn't discover everything, but he showed us how to discover anything. And in that, Isaac Newton unlocked not just the laws of the universe, but the method for finding every law yet to be discovered. This was another episode of Iconic Figures. Subscribe to our channel for more powerful documentaries about the minds and leaders who changed the world.